this video, I'm going to go over using ShowCondorIGC to analyze a flight. First, I am going to download the flights and have them open. I'm not going to go over the full use of this tool in this video, but just as an example, I have a script here which will download and automatically open them in ShowCondorIGC. Because I already have most of them downloaded, I'm just going to select one here for an example, and I copy that. I can also download it to the flight track folder to use as a ghost if I wanted to. And that will download the flight. And then after it's finished downloading, it's going to prompt me to launch it in ShowCondorIGC. So this automatically loads the flights into ShowCondorIGC. And then from here, what I do is I go to calculation, and then if it was a handicap flight, I check that. Otherwise, calculate, and then that will sort the leaderboard by the finish status or the times. So this gives sort of the high-level bird's eye view. And so on here, what I'll do is just do a quick high-level check of the stats. Particularly, the thing that is the most relevant is the climb rate here, which is the average climb rate. I look at that, it just gives a sense of general performance in that area. So the flight I'm going to be looking at is RZ. So look at that, and then I would also look at the VMAT, which is the netto, which is also a very relevant indication of performance, and then the detour percentage. So those are kind of the main performance areas that at a high-level comparison, I can see it compared to the whole pack. And then once I've done that quick high-level view, I will select the comparison tracks, so usually the first and second person, and then the person I'm comparing. I will click that and then click down here to load them up into here, and then from here I click Show IGC. So that loads these flights up into detail view, and once I have them in detail view, I check task time there so that it is sorting everybody by task time, and then I also want time compare on, and this is probably the most useful thing of ShowCondorIGC, is that it has the time delta comparison down here. And the other option that I always turn on is energy-based calculation, so that uses total energy. I prefer that myself. And once I have them loaded up, then the next thing I'm going to do is first do a look at the summary. So this is similar to what we saw in the leader table, except it allows you to see it leg by leg. So I'll take a look at the quick summary comparison. And so one thing that's relevant here is this is basically the compensated task speed, or the cross-country speed, so it's altitude compensated, and that gives a better sense of performance on the legs than just the pure task speed. And so this is altitude lost, this is the climb rate, this is the amount of altitude spent climbing, number of thermals, average per thermal, percentage circling, percentage glide, and this is the glide number, indicated airspeed, true airspeed, average throughout the task. This is the netto. This is the glide number that was better or worse than compared to the expected glide number. So this is showing that basically 12 points better glide than the pure polar, and that is very related to the netto, is why the glide is improved. This is the percentage of the amount flown compared to the distance of the task. So if you see a smaller percentage here, that's generally factoring for the size of the turn point circles, or drifting while thermaling will make it actually a smaller distance flown than the task distance. And yeah, then I go into looking at the same sort of thing, but looking at it on leg by leg, so you can see how the performance was on different legs. So for example, I can see RZ was a fair bit slower on this leg, and so you can see some of the reasons why. The average climb rate was lower, and also the netto was lower. So look at things leg by leg just to get a general sense of how each leg was and what the performance was per leg. So you can see on this leg here was much more closer to on par with the leaders. And the reason for that, it looks like the netto was similar to the same. And yeah, so that's I'm going to look at the summary level. And after I look at the summary level, I would go to a section level, and this is where I start to do the playback scroll by scroll. So before I do that, one thing I can look at is if I right click on this timeline here, it will switch to a thermal view, and each dot represents the different thermals taken, and the percentages of the amount of time spent in those thermals. And so it gives a bit of a visualization of thermaling and thermal choice. And you can typically see it's usually at this section of what were the poorest thermals taken, that is where most of the time is lost. So you see thermals like this will take a lot more time. And I can actually click on the thermal dot, and it will take me to those specific thermals in the timeline. So I can see this thermal here, for example. Actually, yeah, it looks like it lost time, but it didn't when you look at it from this here is the energy compensated climb rate. So if you dive exiting a thermal, it can actually make your climb rate, uncompensated climb rate, look negative. So that will give yeah, a bit of an outline of thermal choices, and you can go here, you can see the best thermal as well by clicking on the dot. So that gives a picture of that, and then I go back to timeline view, and then this is where I do a scroll through, and as I scroll through, you can sort of see moment by moment how the race plays out and transpires and where time is won and lost. So, for example, I can see off the bat, there's some 20 seconds being lost on the starts, and then each section can give specific stats as well. So you can see that this first glide, the netto was negative. So you can see that, and so by the time that glide is done, it's 37 seconds behind. Then we get to the first climb, and this is where you can compare some climbing performance. So you can see that the climb rate here was almost 2 knots lower, and you can also see kind of how the bank angle, radius, and the speed. So it looks like in terms of the bank angle and the speed, it looks actually good because it's a 38-degree bank and not too fast of an airspeed. So then what I would do if I'm looking at kind of a more detailed view of like what's actually happening with the thermaling is I can zoom in, and actually this gives very relevant information sometimes, is what is the shape of the thermaling trace. So you can see, for example, on the red track of DC1, you can see like really, you can see a nice adjusting turn on the entry, and then you see very consistent, very even circles. So typically with thermaling, less is more, where it's just get it centered and then very steady, consistent circles. And you can see with green RZ here that the biggest thing that happens here is there's a very large adjustment happens right here. So shifts the thermal over significantly, and then what happens there is you can see sort of how the climb rate flattens out. So it actually starts climbing worse after that adjustment, and then there's still 3 circles that were done in that poor climb rate. So this would be an area where if adjust the circle and then things get worse, is immediately move on instead of sticking with something that made things worse climb rates. So that's what you can do at a thermal level, and then you can move on in looking at section by section. So you can see again here that not getting as good of a netto. It's harder to tell the reasons for that, although you can see somewhat in the timeline. You can sort of see the spikes in pull-ups to see if the pull-up is maybe too aggressive or not aggressive enough. It might give a little bit of information, particularly if you expand up. You can get maybe a sense of what's happening there in terms of the pull-up. And then, then we get to this segment here. So what happens here is another thermal, which is still not super strong compared to what was ahead. So this is a case where there's really good clouds ahead over top of the hills, which would be, and potentially gliders climbing by that point. So this would have been a better choice just to continue to head for the hills, where there should be a much stronger climb instead of taking a medium climb. And what this shows here, this shows how much time was saved is in positive. So generally a good thing, but this is relative, I believe, to your own thermal average on the task. So even though it shows plus 21, it still isn't as good as what could have been just a little bit further down the road here, where we can see that, for example, there is a 8-knot thermal, and that 8-knot thermal improved HG1's time by almost 2 minutes. So that would be a case of thermal selection. And then here, and it looks like here, for some reason, I'm not sure why, but the climb rate on that same thermal that DC1 and HG1 were getting 8 knots is much, much lower. So my assumption there is that the thermal entry just wasn't well placed in terms of the position with the gaggle. Because at this point, there was likely still a good-sized gaggle in this thermal, so potentially trying to get yourself in reference to the gaggle a bit better would be helpful. And again, you can sort of see here, the circles are shifting around a little bit versus being a little bit more tightly organized. So it looks like there's some entry and centering factors going on there, which gave a not very great climb rate on what was probably the best thermal of the day. So let's continue moving on here. You can see here there's a really good thermal, and you can see even though it was only 5 circles, it improved the time by almost 1.5 minutes. So this was a good thermal. The other thing that you can see in these thermal stats, you can see what the climb rate was on entry and the climb rate was on exit. So it will give a sense of if you're staying in a thermal too long, if you're entering not as well. So let's go back to this thermal. So you can see that the exit of the thermal, or the end of the thermal, was getting poor. Maybe in that case, maybe the thermal had died off by that point. But to me, it looked like it was more a location or position issue within the thermal. And so that's a great thermal. And then continuing on, this is the leg where the performance was quite equivalent to the other gliders. So we can see by this point, before the first leg, see by the first leg there is about 6 minutes behind, and then by the time we get to here it's about 7 minutes, and then this is where a bit of time is gained back. Sometimes this isn't always fully, it sometimes gets out of sorts a little bit around the turn points, so just something to keep in mind. So it looks like on this leg here, still not quite as good of a glide on this one, but maybe because it was a little bit more direct on this leg, then actually the netto was better on this one, so that probably saved a bit of time. So it actually seemed to gain a little bit of time back on this segment here. And then we get to here. So by this point, the thermals were not as strong in this area, so this is about what you could expect. So I can compare to these climbs here, and it's about the same, maybe not quite as good, but similar. Speed, bank angle looks okay, and yeah, then it continues on very similar. It's about the climb rates that the thermals were given, and it looks from here like the final glide might have been compared to basically the leader starting final glide from here. This final glide is starting from here. Maybe it's not too far away actually. It might be similar. And in the final glide, it looks like not quite the same performance on bumping or the line on final, but so a lot of that can just be luck as well in terms of happening into a better energy line. A bit of it's following the clouds, but part of it is just randomness and luck as well. So yeah, that's a bit of a overview of how to use ShowCondorIGC. As I mentioned, you can go into a little bit more detail on each thermal if you want to take a closer look by zooming in and looking at the actual track on there to get a sense of kind of the thermaling organization and pattern. So this circle here looks like a little better, a little more organized. And that will just give a bit of idea. So you can see this one where it was the best climb was good entry and nice circle. So typically less is more when thermaling. And yeah, that's about that.